PolyAPI Use Case, Workflow Automation by Darko Vukovic, CEO, PolyAPI, March 20th, 2025. Workflow automation enhances business efficiency by accelerating workflow execution, improving the accuracy of information transfer, and enabling scalability beyond what is possible with manual processes. In today's business landscape, automation is essential for success. There are many automation tools available, from low or no-code platforms like Zapier to RPA tools like UiPath, each catering to different user needs. While PolyAPI can handle most workflow automation scenarios, it is specialized for complex, scalable, and robust automation needs that require developer-driven precision and flexibility. By providing a powerful, function-driven platform, PolyAPI enables teams to build workflows that seamlessly integrate with enterprise systems, ensuring long-term maintainability and performance at scale. Example, in hospitality, an advanced deposit collection system that automatically applies PMS reservation policies to capture payments or generate payment links via a payment processor like Adyen. This reduces hotel staff workload and improves operational efficiency. Example in retail, an inventory management automation that dynamically adjusts inventory levels based on sales, returns, or deliveries. These workflows can also automate reordering and inventory balancing across distribution centers as needed. PolyAPI provides essential capabilities for building and operating workflow automations, including a gateway for receiving real-time events or triggering scheduled jobs, microservices for implementing workflow orchestration logic, and an SDK that simplifies integration with internal systems and software as a service applications. These components make developing workflow automations with PolyAPI efficient and straightforward. Key objectives. Every business has unique operational needs, but most enterprises seek similar benefits from workflow automation. The primary drivers are efficiency, accuracy, scalability, and flexibility. Efficiency reduces processing time by automating repetitive tasks and streamlining data flow between systems. Automated workflows ensure that actions are taken immediately based on new inputs, eliminating delays caused by manual intervention. Accuracy improves data integrity by minimizing human errors in data entry, validation, and decision-making. Automated workflows enforce consistent rules and eliminate inconsistencies, ensuring reliable and precise data exchanges. Scalability supports growing operational demands by handling increasing volumes of events, transactions, and processes without requiring proportional increases in staffing. Automated workflows can dynamically scale to accommodate business growth and fluctuating workloads. Flexibility adapts to changing business requirements by enabling customization and seamless integration with internal systems and third-party applications. Well-designed automation can evolve alongside business needs without requiring major rework. If these objectives align with your needs, keep reading to see how PolyAPI can help. How PolyAPI helps. PolyAPI simplifies workflow automation by providing 4 core capabilities. The inbound gateway is essential for managing inbound events from various sources, handling authentication and authorization, and routing requests for processing. It also manages scheduled job triggers for orchestrations that need to run at specific times. Microservices execute workflow logic, including data transformation, validation, logging, and orchestrations that automate complex processes. PolyAPI's SDK and AI assistant enable secure and efficient connections to underlying systems through the Outbound Gateway, which ensures smooth interactions between microservices and external applications. Notably, the inbound and outbound gateways are part of the same service, with different capabilities activated depending on the flow of messages. Here's a high-level diagram illustrating these capabilities. Inbound gateway. The inbound gateway acts as the entry point for events originating from external systems such as webhook notifications following an event-driven architecture, GraphQL subscription events coming soon, or Kafka messages coming soon placed on a topic. Its primary function is to receive and authenticate incoming requests using PolyAPI keys or specialized security functions before routing them to microservices or subscribing clients connected via WebSockets. The inbound gateway can also generate its own events based on scheduled jobs, automatically triggering microservices to execute time-sensitive workflows. Microservices, server functions. Microservices implemented as server functions operate within a serverless environment managed by Knative on Kubernetes clusters. These functions are designed to scale automatically and can be written in TypeScript, Python, or Java, with C# support coming soon. Microservices define the logic of workflow automations, handling validations, data transformations, routing, and API calls. They can be event-driven, responding to incoming triggers, or scheduled for periodic synchronizations. Whether processing individual messages or bulk operations, microservices integrate seamlessly with external libraries and leverage PolyAPI's SDK to interact with other microservices within the platform. SDK Developer Toolkit. The SDK simplifies interactions between microservices and external systems by providing a rich set of tools and pre-built functions. It includes a comprehensive library of API calls, utility functions, and secure mechanisms for managing credentials and system variables. Customers can take advantage of PolyAPI's pre-built integrations with popular enterprise systems or define their own private functions tailored to specific business needs. By abstracting complexities such as error handling, authentication, and system traceability, the SDK allows developers to focus on business logic, while PolyAPI ensures reliable connectivity and secure transactions. The SDK simplifies interactions between microservices and external systems by providing a rich set of tools and pre-built functions. It includes a comprehensive library of API calls, utility functions, and secure mechanisms for managing credentials and system variables. Customers can take advantage of PolyAPI's pre-built integrations with popular enterprise systems or define their own private functions tailored to specific business needs. By abstracting complexities such as error handling, authentication, and system traceability, the SDK allows developers to focus on business logic, while PolyAPI ensures reliable connectivity and secure transactions. Detailed capabilities of each service. If you are interested in learning about the specific features that enable workflow automation, the following section outlines the detailed capabilities of PolyAPI. Gateway, inbound and outbound. The gateway serves as the entry and exit point for workflow automation, handling incoming events, authenticating requests, and routing them for processing. It ensures seamless communication between systems by triggering automated workflows and orchestrating outbound interactions. Webhook listeners receive incoming HTTP's requests from various systems and convert them into internal events that trigger automated workflows. Responses can be immediate acknowledgement or a synchronous response after the execution of the workflow. GraphQL subscriptions coming soon. enable native connections for real-time event-driven workflows, such as Oracle Hospitality Integration Platform Streaming or other subscription-based systems. In the meantime, an always-on server function can act as a bridge to achieve similar automation. Kafka Subscriber, coming soon. Allow workflows to consume and respond to high-volume, event-driven data streams, enabling real-time automation based on message topics. Similarly, can be implemented as a dedicated server function today. Error Handler. Detect and capture failed workflow executions or API calls, triggering automated diagnostics, alerts, or incident responses to improve reliability. Execute endpoints. Enable workflows to be manually triggered via the UI or API, allowing for controlled testing, re-execution of failed processes, or ad hoc workflow execution. Execution IDs. Assign a unique execution ID to each request, ensuring traceability throughout the automation pipeline. This allows for detailed monitoring and debugging across workflows. Security functions. Validate requests before they are processed, ensuring only authorized events trigger automations and reducing the risk of unintended executions. Variable and secret injection. Securely pass credentials and dynamic configuration values within workflow execution, ensuring sensitive information is handled safely. Triggers. Define how events initiate automated workflows. Whether triggered by a webhook, GraphQL subscription, Kafka message, or error event, workflows can execute synchronously or asynchronously, depending on business needs. Metrics. Track execution times for each step in a workflow, providing insights for performance monitoring and optimization. Logging. Capture logs from multiple systems to provide full visibility into workflow executions, making troubleshooting and auditability seamless. Scalability. Dynamically scales with Kubernetes to handle high-volume event processing without bottlenecks, ensuring workflows can operate efficiently at any load. Microservices, server functions. Microservices handle the execution of workflow automation logic, ensuring that processes run efficiently, reliably, and at scale. Language support. Develop microservices in TypeScript, Python, or Java, with C# support coming soon, leveraging built-in libraries and system integrations. Interface schemas. Define structured request and response formats, ensuring workflows receive and process data accurately. Variables. Retrieve configurations dynamically, such as system mappings, lookup tables, and business rules, allowing workflows to adapt in real time. Can be used in a multi-tenant fashion to allow for single workflows to cater to many different mappings or rules. Client functions. Create reusable code blocks that can be used across multiple workflows, reducing redundancy and ensuring consistency. Can be used in a multi-tenant fashion to allow for different execution blocks based on the customer or partner that the automation is for. AI services, coming soon. Enable intelligent workflow automation by allowing AI-powered decision-making and processing without requiring complex logic at runtime. Read more about our short-term vision here. IDEs and local testing. Develop using any preferred IDE with full debugging support, allowing for real-time validation and iteration of workflow logic. Deployment. Integrate with CI/CD pipelines for streamlined releases, ensuring controlled and scalable deployment of workflow automation updates, catalog, and management service. Automatically track and manage deployed workflows, providing visibility and maintainability through a centralized repository. Execution console. Manually trigger workflows from the management UI for testing, troubleshooting, and validating automation logic before full deployment. Logs capture execution details, including error conditions, timestamps, and performance metrics, ensuring workflow reliability and traceability. Scalability dynamically scales using Kubernetes and K-native to handle increasing workflow execution demands without performance degradation. Sleep mode optimizes resource usage by putting workflows into sleep mode when idle, while automatically scaling up when triggered. Cloud provider optionality. Maintain consistent workflow automation across various cloud providers, avoiding vendor lock-in and ensuring flexibility. SDK and AI Assistant. The SDK accelerates workflow automation development by simplifying integrations and providing reusable components, API, server, client, variable, and AI functions. Provide reusable, modular components that let developers focus on workflow logic while ensuring consistency in inputs and outputs. This approach reduces redundancy and minimizes risk as changes remain isolated and do not disrupt the entire workflow. Type schemas provide secure authentication and role-based access to workflows, ensuring that only authorized processes execute. Function discovery enable teams to quickly find and reuse existing workflow functions, promoting efficiency and reducing duplication. Code generation. Accelerate the development of automation workflows by generating API call, scaffolding, and integration logic. General development help. Leverage AI-powered assistance to improve development productivity, making it easier to build, test, and deploy workflow automations efficiently. How PolyAPI is different from market alternatives. PolyAPI takes a fundamentally different approach compared to traditional integration platform as a service or automation platforms by prioritizing developers and native development. This focus enables unmatched capabilities and architectural advantages that streamline automation, improve maintainability, and enhance scalability. Function-centric approach. PolyAPI is built around a function-first design. Microservices operate as server functions. Underlying APIs are encapsulated as API functions, and soon AI services will be structured as functions as well. This unified approach ensures seamless interoperability, reusability, and maintainability, reducing risks when updating or modifying workflows. Native development alignment. Workflows are developed using native programming languages, allowing developers to import libraries, use familiar IDEs, and integrate seamlessly with existing runtime environments, CI/CD pipelines, automated testing frameworks, and source control systems. This eliminates the constraints of low-code platforms while ensuring full compatibility with enterprise development standards. Multi-tenant workflow architecture. PolyAPI enables workflows to dynamically adapt at runtime by parameterizing context paths. This allows the same workflow to be executed across multiple customers or partners while applying different rules, mappings, and logic without requiring modifications, ensuring scalability and flexibility in automation. AI-assisted development. PolyAPI's AI Assistant dynamically references the entire function catalog, including customer-specific functions, to generate high-quality code based on the developer's input. Future enhancements will enable AI to evaluate function version updates, detect underlying API changes, and suggest remediation for dependent functions, further simplifying maintenance. Systematized knowledge capture. PolyAPI captures and organizes all integration-related information, from ingesting open API specs and observing API behavior in Postman to storing runtime function code, variables, configurations, and logs. This ensures that all critical data is available for troubleshooting, maintenance, and future development, reducing technical debt and knowledge gaps. Unified Gateway for event-driven automation. PolyAPI's Unified Execution Gateway simplifies troubleshooting, testing, and maintenance by providing a single point for handling events, invoking functions, and monitoring execution. This approach ensures consistent error handling, making it easier to detect and resolve issues when APIs or workflows misbehave. On-demand SDK generation. PolyAPI generates native SDKs with fully documented schemas for all function types. This enables developers to leverage IDE features like type-ahead suggestions and debugging tools, allowing them to focus on business logic while reusing existing building blocks. As new functions are added, future workflows benefit from modular reusable components. Native Vault integration. Sensitive credentials and secrets are securely managed within PolyAPI's Vault, ensuring they are never exposed to developers or server functions. This eliminates the risk of credential leaks while allowing workflows to securely reference stored credentials when interacting with external systems. Kubernetes native and cloud agnostic. Designed to run natively on Kubernetes, PolyAPI supports deployment on AWS, Azure, GCP, or private cloud environments. This guarantees scalability, high availability, and flexible hosting options, allowing organizations to deploy PolyAPI in a way that best fits their infrastructure. For teams preferring a managed approach, PolyAPI is also available as a fully managed platform as a service. AI services coming soon. PolyAPI is working on AI-powered workflow execution that will eliminate the need for code in specific use cases. These AI-driven workflows will enable dynamic data mapping in real time, making them ideal for low-volume, latency-insensitive integrations that enterprise teams typically struggle to automate. Read more about our short-term vision here. PolyAPI's developer-first approach ensures that workflow automation remains scalable, flexible, and maintainable, a stark contrast to the rigid, vendor-locked models of traditional automation platforms. Automate smarter with PolyAPI ... PolyAPI transforms how enterprises approach workflow automation, providing a developer-first platform that balances flexibility, scalability, and control. Unlike rigid integration platform as a service solutions or low-code automation tools, PolyAPI enables teams to build, operate, and scale workflows using native development practices, ensuring seamless integration with existing infrastructure. With a function-driven architecture, real-time event handling, secure execution through a unified gateway, on-demand SDK generation, and AI-assisted development, PolyAPI empowers enterprises to automate with precision, efficiency, and maintainability. Built to run natively on Kubernetes and deployable across AWS, Azure, and GCP, it offers the freedom to automate without vendor lock-in. Ready to take automation to the next level? Reach out. Email us at hello@polyapi.io. Try our platform by signing up on our website or book a time to meet with us in person.